Welcome back. So in this lecture, we are going to be talking about makefiles, what they are, why we use them, and how we use them, okay? Now, before we go into the lecture, I just want to make some few points here. So this program in front of me is already attached in the resource folder, so you don't have to copy all of this while I'm writing. So this is just a demonstration, and I'm going to explain what this code does in a few seconds, okay? So what is a makefile? Now, a makefile is a file containing a set of rules used to build our programs, okay? So it's a form of automation, especially when we are working with multiple files, okay? And we've talked about working with multiple files, separating stuff into modules and stuff like that. And it's a very good opportunity to learn about what makefiles are and how we use them. Now let's explain the program in front of me here, and before we start to write our makefile. So in this main function, you can see that I have my header file, functions.h, and in functions.h I have the start and square root function. Now these functions are distributed into three files, okay? We have function 1 holding the square root function, function 2 holding the start function, and function 3 holding the end function. Okay, now we are going to use all these files or all these functions in the main program. So first we start the program with the start function, and we end the program with the end function. And you can see here we are using the square root function to get the square root of a particular number of 5. Okay, now usually, due to our previous knowledge, the way we compile these kinds of code is, let's go into our terminal, okay? And let's compile it the way that we know how to compile it. So now I go into my desktop, okay, as usual. And because I have my C files inside a function folder, I just go into that. And you can see we have all our files here. Now we compile this by saying CLANG war function1.c. And I just want to expand this here so I can improve the surface area of this. So we continue and say function3.c, okay, and don't forget the main.c file. Now the object file, let's just name this m so it's more convenient for us to compile. Okay, so we are compiling our three files, function 1, 2, 3, and let's see how this goes. And now let's say ls, you can see we have our object file here containing the executable binary that the compiler has generated for us. So let's come here, and you can see that our program successfully executes. But what if we had more than 3 C files? Even doing this is very inconvenient, okay? It's not efficient, and that's why we need makefiles. They help us make compilation very simple. Now, how do we create our makefile? Now, the way we do it is we can come here and say touch makefile, okay? Now, this capital M is very important as it is a standard, okay? So your makefile has to start with a capital letter M because it's a standard. So we are going to touch this makefile and open makefile. Okay, now we have something that seems to be a text file. Okay, now this is the way it's supposed to look like. Okay, it's supposed to look like a text file. Okay, and the first thing we are going to introduce here is the way we comment in a makefile. So if we wanted to make a comment, and we can start it with an hashtag, and then we can say this is a makefile. Okay, so the compiler is going to ignore this directive, okay, because it's just a comment and it starts with a hashtag. Okay, now the next thing we're going to talk about is target. Now the rule of targets are just to hold or include the executable files and objects that we want to work with. Okay, now the first target we're going to be working on is all. And we're going to start simple, okay, for you to understand what we're doing here. Now, all is basically when our compiler goes into the makefile, it's saying compile every single thing in this file, regardless of whatever is in it, okay? So we can come down here to the second line, and use your tab, okay? Not spaces, tab. And this is very important, okay? So when I go tab, I can come here, and instead of actually writing this, let's copy what we've already written here, okay? Okay, so now I have clang wall function1.c, and you can see every single thing is here, okay? So now I can save this as this. Now let's change the executable file to something different, okay? So we can see what's going on here. Now we have a basic makefile, okay? If I use this makefile right now, I expect the compiler to give me the output of my three functions. Let's go back into the terminal. Now, how do we use this? The keyword for using makefiles or for compiling a makefile is the name make, okay? So just go in here and say make. Now, when we click on make, you can see we have all of this being executed here. And we can go into the file by see what's inside, and then you can see we have an executable file called func. Now we can execute this func and you see the result of our program. Let's go back here. What if we don't want to execute like this? How would we do it? Now we have another keyword called exec, okay? And we can just add the rules for compilation. So we can say compile func like this, and we can go back and say make, okay? Now when we have said make, we can come here and say let's say ls here, okay? And then we can say make exec, okay? And now when we use make exec, you can see how it called this first because this is the command we are asking it to perform, and then we executed our function or our program, okay? So doing this is probably a very long way and not really, efficient as we would want it to be. Now, the second thing you should take out is when we make a file here, so we also want to be able to clean out the executable file that we've kind of created here. So we can use another keyword here called clean, okay? And tab. Now what we want to do is remove this func, okay? Nothing special. So what we can do here is we can come down and use the rm keyword, okay? Then rf func. That's since we're just working with this particular thing, okay? And actually you can have many remove commands here. So if you're on a Windows computer, you might want to use something like this because so it's % and .exe. Now what this is, or what this signifies, is remove all object files that has the exe sign here, okay? You can also go down here and say remove rf, okay? Come down here, okay? So we can come here and remove everything .o, okay? So now we save this. Let us make clean and see what happens. Now if we check here, you can see that not only did func get deleted, m also got deleted because we are using this command here, and that's why m got deleted. So it's an object file, and this works on a Windows machine, okay? Because the executable files are different. So that's how we do the cleaning process here, okay? It's as simple as that. Now when we are writing makefiles, we want our makefiles to be as efficient as possible, and so let's introduce something that we call constants. And what constants do here is they just help us fill in the gaps and make our lives easier. So an example of a constant that we can use here is cc. Okay, so cc is the normal standard for C programs. So we are going to use cc here, and what we're going to store here is the name of our compiler. Now the name of our compiler is CLANG, remember? Okay, so we're just going to keep CLANG here. And the next constant we're going to use is C flags. Now C flags holds every single flags that we have. So that's, in this case, we're just using dash wall. Now when we have these constants, we can replace them in our all here. So we can say the way we can replace this is by using a dollar sign. Okay, now your brackets, open and close bracket, and we can say CC here. Now instead of wall, let's copy this. So we can have the percent, that, and C flags. Now this is just syntax wise, okay? This is just syntax wise how we can use our flags to compile, okay? Nothing different. You can also keep RM in the flag if you wanted to, and you know, replace things like that. We could also replace our object file here. So we can say we had constant name that, and we wanted to make func be inside that. All we need to do again is use obj here, okay, and fill it in the dependency. So we can go back here and say make, okay, not that kind of make. Okay, now you see that we have the same thing coming out here because the compiler sees every single thing as, you know, it fills in this gap for us when it's compiling. Okay, so now we have this, we can come here and say and execute the file, and we still have the same result as we expected. Okay, now this is the basic way you would use to compile all your C files. Just keep them here and kind of compile them like this, but we can actually go further. Okay, so say for instance we wanted separate object files. Okay, we wanted to be able to access some object files, let's say the object file of function1.c, then we have to compile them separately and meet ourselves like halfway. And the way we do that is by using these separate object files. Okay, so this is what we are going to do now. So if we wanted function1's object file, so we say function1, not function, so function1.o, okay. And what we're going to do here is the name of the file, the C file that we want to work on, that is function1.c, and tab again, make sure it's tab. And what we can do here is bring in this particular code, okay, and say that. Now we can get the separate object file for function1.o, and we can do this for our 3 functions. Okay, so we're just going to copy this and come down here. Okay, okay, so we have function 1 and function 2, we have function 3. We also have our main file, so main here, so we have to change this also, don't forget. 3, so this goes to 2. And this becomes main. Okay, so main here. Okay, now we have, or we are going to have, separate object files. Now what do we do with this when we already have this? Now we can just rename this and make this an object file on its own. So all here could represent, let's say in this case, let's say obj. Okay, let's come here and say obj, and we can just come here. And so instead of doing this, we can come down here and say okay, make sure is this obj, and do that. So what we want to do here is we want all the files or all the object files, because we already have them. So function1.o separated by space, not that o, so function 2.o, function 3.o, okay, and main.o. So now we can just compile all of this separately. Okay, so what we can do here is just say replace the C with an O, replace this with an O, and just keep that right there. So we're just going to replace every single thing here. Let's save this. So let's see if we have made any mistakes. So now let's go back, let's see and check if everything is okay. Now one issue that arises is usually with the linker, okay? So the thing is that when C goes into this file, it tries to find some functions that are there. So in this case, it's square root. So immediately, if it doesn't find square root, it's going to give us an error. Now we know that square root is in the header file right here. And because we know that, we are just going to avoid linkage errors, and the way we do that is by using the C flag. Okay, so this is going to avoid any error regarding clashing or C in quote not finding a particular function. Okay, so now we have this, we have our object files, and we are compiling all of this properly. Let's go into our terminal and compile this. Okay, and now you can see we have compiled all our files here. And if we wanted to run this, just as usual, we would do it like this, and you can see the program runs perfectly. Let's go down here. Now you can see we have separate object files. Okay, now what an object file allows us to do is we can use the functions from this method just by the object file. Okay, so it's the compilation of the overall program. Okay, so it's just like when we had a.out, and we could keep compiling a.out and still get results. Okay, so it's good to know that you can do this, and this is how you can build a simple makefile to compile your program. Okay, so we're not going to go into depth what makefiles are, what magic stuff we can do with makefiles. In fact, there's an entire book for that. Okay, all we need to do is compile our files, compile our multiple files, and we have learned how to do that. So that's all you need to know about makefiles at this point. Okay.